Well, good morning, my algebros. Last time we looked at zero exponents, and anything to the zero power is 1. And we looked at negative exponents, which means we take the ticket. If it's a negative exponent and it's a whole number, then it becomes a fraction. And if it's a fraction, it becomes a whole number. Today we're looking at multiplication properties of exponents and division properties of exponents. So far we've covered 2 rules of exponents, and today we're going to cover a few more. So make sure that you take good notes on these if you're doing this at home. Remember, at the end of all of this, you're going to make me a video explaining the 9 exponent rules. Okay, let's take this product of powers. Product of powers. So the rule is, if you have the same base, a to the m times a to the n, the same base as a, then you can add the exponent powers. So a product means to multiply. And so when we have powers that have the same base like this, 2 to the third times 2 to the second, we can add the exponents. Why is that? Why can we do that? Well, because we know 2 to the second power, or 2 to the third would be 2 times 2 times 2, right? And then we know that 2 to the second power is another 2. So the total is 5. 1, 2, 3, 4, 5. And that is how we get this 2 to the 5th. So the rule, though, important to know all of our rules, right? Just like we talked about soccer and knowing how you never touch the ball with your hands, but then there's the keeper that can touch it, but only inside the box. And then you can also throw in the ball, but it has to have 2 hands in the ball, over your head, can't be to the side, both feet on the ground. So we need to know all these rules, just like we memorize rules to a sport, right? And of course, the last thing we want to do is make sure we finish by doing 2 to the 5th on our calculators, which is 32. All right, I'm just going to skip that one real quick. Let's take another one. Let's say I have 6 to the second times 2 to the third times 6 to the first, obviously, because it's one of them, and then 2 to the second. Well, I can combine my common bases, right? So I can only do this with the same base. So 6 to the second and 6 to the first is obviously going to be 6 to the third. And then 2 to the third and 2 to the second is going to be 2 to the fifth. So then I have 6 to the third and 2 to the fifth. And I want to resolve these and then multiply it out, right? Now, again, we're going to start doing those optional things. You should be able to see straight from the first step to that third step and then resolve it on your calculator. You try. Go ahead and give it a whirl on these. Oop, notice that we have some 0 and negative exponents. If you're doing this at home, please pause your video. Okay, let's see how we did. So instead of having on number 1 to write it as a fraction and then resolve it, we know we can just do the math. 3 minus 1 is 2, right? On the second one, we know, first of all, that 3 to the 0 power is 1, so we're not worried about that one anymore. Then we know we'll just have 3 to the 4th. Then we have 5 to the second and 5 to the negative first, so we subtract and get 5 to the first power. So then 3 to the 4th is 81 times 5 is 405. All right, let's look at power of a power. Well, what is this about? Well, we're going to be using those parentheses that we've talked about before. And it means it's multiplying, right? So we know that just like when we distribute, it's multiplication here too. This is nothing new, right? So we just need to know that everybody in the parentheses gets the power, that outside power. So let's start simply. Instead of adding these this time, we would multiply them, right? Because when I look at it, if I were to think about it logically, I know that it's 2 to the third power twice, right? 2 to the third power twice. So that means I'd have 2 to the third, which is this, and then I'd have another one, right? Which is obviously 6, not 5. And that's why this works. And we get, finally, I always want to resolve it, 2 to the 6th power 64. Don't forget that step. It's really crucial. Now, number 2, we have parentheses here. That means everybody in the parentheses gets the -3. So obviously this is going to be a fraction, right? Because it's a negative. And we know that it's going to first take the ticket and go downstairs. And then it's going to be resolved, right? All of these steps you should be able to skip, right? Because you should know you just take the ticket and then resolve it. And -4 times -4 times -4 is a -64. Okay, another rule. So this is our third rule for today, power of a product. What this means is inside of our parentheses, we already have things that are multiplied. Maybe they have the same base, maybe they have a different base. In this case, it's a different base. And then we have it to a power. So we have to distribute, right? We're just distributing. Everybody in the family gets the power. Now here on number 1, we have 2 to the first power, right? Because if it was 0, it would be 1. And we need to remember to distribute it to everything. So we'll have 2 to the 2nd times x to the 4th times y to the 6th, right? Where am I getting that? Because I'm distributing it, multiplying it out, and then I go ahead and resolve my exponents that I can. So I know it's going to be 4x to the 4th, y to the 6th. Let's try another one. Because of course we're going to throw in some negative exponents here, right? 2 ways to resolve this. I can first take the ticket and then do the power, but why not just go ahead and give the power first? So when I do this, I get the power, and now I have to take the ticket, right? So again, you could go from this step right here all the way down to this step, because we know how to use our powers. Let's take a look at this one. Of course, we're going to throw in a 0 power while we're at it. So the 3 on the outside, it has nothing. It just has to wait for the powers to be distributed, right? It doesn't change. So we get a to the 2nd times, to the 3rd power though, and then b is going to be 1, so we don't care, right? So we just end up with 3a to the 6th. And again, you should be able to get from this step to this step and skip all the in-between things. But I show you all those because I like people to see what the thinking happens. Let's take a look at this. Again, the 2 on the outside is separate, right? It's not inside the parentheses. It doesn't get the 3rd power, but everybody else does, right? So I know that 4 gets the 3rd power, and a to the -2nd gets the 3rd power, and b to the 4th gets the 3rd power. So I end up with 2 times 4 to the 3rd, a to the -6th, and b to the 12th. Now I need to take some tickets. So I have 2 times 4 to the 3rd times, and I move a to the 6th downstairs, and then b to the 12th. Not done yet, because I have 4 to the third power 64. And then I have to, my last step is to multiply that 64 times 2, and I get 128, b to the 12th, a to the 6th. Okay, let's try some U-tries. Pause your video here and see how you did. Hopefully this is what you got. If you have any questions, give me an email or see me on Zoom. Don't forget, I really strongly suggest that you get the HMH Fuse app. It's our textbook app. It's only $19.99. I know I sound like a TV salesperson here, but it has videos, video lessons embedded, and it has all of the solutions for all the odd numbered problems, including the word problems. It goes step by step. It's really an invaluable app. I really like it. Yeah, that would be my suggestion. We're going to go ahead and do this homework right now in class. Going to give you guys about 15 minutes to start on it before we go to the division properties of exponents today. Okay, this is called 6-1 part A, right? A.